Hi guys, welcome back to the next video. In this video, we are going to talk about ECS. So this is the first topic we're going to start in terms of understanding your complete AWS compute service. We've already seen multiple locations and EC2 instance, so we're not going to talk about it. But we are going to create a ECS instance and then we are going to work with it. Now, ECS instance comes with two options. Either you can go with Fargate or EC2 instance. In this particular video, we are going to use the ECS with the EC2 instance rather than Fargate. Further down the line, you will see on this particular section, we will be talking about ECS using Fargate and working with ECS on Fargate. So that's basically a serverless compute service. All right, so let's go down on this path for the ECS using EC2. So go ahead and call upon the service ECS and then middle click it to open it in a new tab. Now do remember that this is a multi-part configuration. So we're going to configure multiple items over here. And finally, we're going to get our cluster going. Okay. So this is the first thing I'm going to start with in this video. So firstly, we're going to configure a cluster. So click on create cluster. So this is how you can interact with the ECS service by having a cluster created. Now cluster gives you the infrastructure for you to run a container, but we will not be creating a container while we create a cluster. So what we will do is like first step is to create an infrastructure like cluster, wherein which we will be specifying the number of instances to be running to a cluster. And then we will do a task definition. In that task, we will be specifying what kind of a container we want to run as part of this cluster. And we will be also configuring a service under the cluster and integrate the task. And then have that task run. And then the cluster will be, the service inside the cluster will start popping up with containers. So let's click on create cluster. So first step is to create a cluster. So I'm going to give HTTP ECS cluster. Now this is going to be the name of my cluster. So this will tell me that it is a HTTP where I'm using this application, Nginx application for HTTP request. ECS as in towards it's what we are doing container service, and then it's a cluster. So this is just to define that. So when you create a cluster name, you're going to get the namespace also allocated to it. So you're going to see a namespace assigned over there. Now, in this situation, we are choosing EC2 rather than Fargate. Fargate is basically, you don't have to specify any EC2 server instance like this. If you select this, you can see that automatically it will create or generate a serverless compute service, which is zero maintenance. But in terms of EC2 instance, there's a maintenance required where you will be actually having the EC2 instance created. Sorry about the background noise. So here you have the ASG. So this is nothing but auto-scaling group. Auto-scaling group, we will talk about it later point of time. I think it is covered over here. So we will talk much more in detail about auto-scaling groups, but here just overview. So we will be creating auto-scaling groups and gradually it will scale up. So we will normally define the minimum and the maximum desired capacity. Okay, so minimum means like the number of servers needs to be created minimum, like it should be always maintained. So which means that it will not scale down from the minimum, but it will scale up to the maximum. So, or you can say scaling out to the maximum and scaling in to the minimum. So minimum we can keep it as 1 and maximum we can keep it as 5. So this ensures that the maximum number of servers which it may create is 5 and a minimum it will maintain all the time is 1. Now there are two options here in terms of provisioning model for your auto-scaling group. One is on-demand and spot instance. These are the type of instance. Okay, so we have discussed enough about it. On-demand instance is basically pay as you go, and there is no long-term commitments or upfront cost is required for it, which means that you create a EC2 instance by going to EC2. So that's basically an an on-demand instance, right? So the same thing is what we are doing over here. So we need this load to be running all the time, and this is for a web content, right? So we need it. But spot instance, on the other hand, enables you to save 90% which is discount applied to you. But the only problem is like it will use the unused EC2 resource capacity. But the utilization becomes higher and there is no unused space, then obviously you will not have service to be disposed. So there's a risk of not having any service available for you. So we want to go without the risk because we need at least some service to be running all the time, and you will go for on demand in this case. The next one is about the container instance AMI. So what this container instance, there are two wordings we're going to see later point of time. One is the container and the container instance. Container instance is basically where the containers will be hosted. So this is really required for you to choose the instance type over here. I've done this using this T2 micro, but it is very slow. So I'm going to go with T2 large or medium. Medium is much better. So I'm going to go with T2 medium, which has two CPUs and 4 GB of RAM. Now in over here, I'm going to use create new roles over here. So if you don't have anything and it comes by default to create new role, then very good. So just go with this. It's just coming because I've already tried this. So that, that's the reason why there's an already a role exists in this name. So just go with create new role, shouldn't be a problem. Terms of key pair, just use the default key pair which you have. So I've just chosen Tomcat over here because I have that key pair. I also have Docker Kube as well, so I'll choose that. So whichever we have done so far, we have worked with on the such key pairs, just choose that and it should be fine. In terms of network settings, you're gonna use the default VPC and all the subnets available, which means all availability zones. So this 5 instance can be created across all these 5 availability zones. So use the existing security group. I've just given this, it has taken the default security group. If you're not sure about this, go to EC2, go to security group, and then search for the security group. Okay, and then you understand that this is all traffic security group. All the incoming traffic is accepted by default. All right, now that we have completed this task, now let's go ahead with the auto assign public IP address. It's just basically use the subnet setting. We don't want to give any specific setting over here. Monitoring is optional, and I don't want to go for monitoring because of the charges it may occur while monitoring is in place. Encryption again is optional for your managed store as well as Fargate ephemeral storage. So we're not using Fargate as of now. If you want to encrypt it, create a KMS key, and then you can choose that, KMS key over here. So that's basically will encrypt the data using the key. But we don't need it right now. We don't need any encryption. If you have any tags to be specified for this cluster, you can add those tags here. So click on create. Okay, so now the cluster is getting created. Well, the cluster creation may take about 5 to 10 minutes. So for me, it's just still in progress. And you can see that the cluster creation, task definition, service creation, everything will be done through CloudFormation. Because CloudFormation is basically the stepping stone of every bit of ECS configuration, because ECS is like small components, and those small components are run together. And how it is run together is through CloudFormation. So you will see CloudFormation coming in almost everywhere. So now that you have created the cluster, just click on the cluster and you can actually see some detail about the cluster in the overview. You'll get much more detail once it finishes this cluster creation. You will see services, task, infrastructure. Infrastructure, it needs to provision that one server. So it's still provisioning that one server, the container instance. So that will come up over here once it has done it. And then metrics is going to come over here, and then schedule task. Now, task is basically how we create containers. So this is basically what we call it as a task definition. We'll do it in a moment. But what is task definition is basically a task is nothing but a blueprint of your application. It's basically a text file in JSON format that describes the parameters which the container needs to have. Okay, so it can have specification like what kind of a launch type to use, and it can have like what Docker image you want to run as part of the container, what is the CPU memory utilization statistics, how much you want the CPU memory to be assigned for each container, how much memory requirements you have, that also can be mentioned. You have soft limit and hard limit, and then what operating system you want it to be run, operating system, Docker image, so it's all the same. And also it talks about login configuration, so you can use logs to put it across to understand what's the work going on. And then it could be about environment variables which needs to be run. You can also set, if you have multiple containers, you can also set the priority for each container to start first, which one to start first, likewise. So all those things should be defined in a task, and the task will be run through a service. Okay, the service will call for those tasks, and that service will execute the task. Okay, so what we have done so far is like creating an infrastructure for your containers to run. So now you can see that a container instance is created. So this is the instance ID. So this basically will go to EC2 instance. So if you see EC2 instance, right, if you go to instance, you will see this instance running right now. So I have like previously tested ones over here. So this one is the one which I created for this particular example. So if you just copy this instance ID and search it over here, you can see that it matches. So this is the instance ID it's created. So now the deployment is completed, right? So now that's why it is coming up. So this particular cloud formation is also completed. So create complete. So this is also done. So cloud formation is done. Instance, your container instance is created, and you're ready to create a task definition. So click on task definition, create a new task definition. So here I'm creating a task definition for my HTTP service on task, HTTP task. And here you have to select the same one, which is EC2 instance rather than Fargate compute container. Now do remember that if you select Fargate, then you should have also selected the cluster type as Fargate, okay, or else it will be confusing. So it's better to select the same thing. So Amazon EC2 instance over here. Now this is the infrastructure requirement for your task where your container will be created. So now we are not talking about your family, instance type and instance family or instance type, size. So here we are talking about the container needs to be, this is the allocation of the container. So this is the infrastructure requirement of a container. So here network mode is AWS VPC. Operating system architecture is Linux x86 64. CPU is one CPU, and going with 1 GB of RAM. So my virtual machine, medium virtual machine, consists of 3 GB of RAM. So I'm gonna go with one virtual CPU, one memory. Here I don't have to select anything about the task role or task execution. You can ignore it. And here you're gonna get this one saying that create a new role over here. So this is how it's gonna be. So leave it as it is. The next one is about the essential container. So this is the container which is going to be coming as part of your task. Okay. So you have specified the task requirement for this task definition. So if you want to run this particular task on a cluster, that cluster should have one virtual CPU, one memory, and it should have like Linux x86. So this is the requirement. So once you have completed the requirement, it should match the requirement of your cluster. Your cluster has 3 GB of memory, but I've given 1 GB as a requirement. So your requirement is done. So it will validate the requirement with your current cluster configuration, and it will say it is successful. Okay, so the second one is basically your container. Container is basically where what you're going to have or run on your container. So firstly, we're gonna say I'm gonna run Nginx or HTTP service on Nginx, and then you have to give a full repository URL. Now this repository URL should be taken from something called Elastic Container repository. So this is the ECR. So you can see that if you just click on it, it will open a new tab. So Elastic Container Registry, sorry, not repository. Registry contains all the repositories, both public and private repositories. So what does this means? This means is that you will, if you want to specify Nginx image over here, you can either create a private repository or you can create a public repository. Okay, so now that you have these two options over here available for you, then all you have to do is like put that URL over here, but you don't know the URL right now. So you need to get that URL of Nginx from this particular ECR. So to get that from this public repository, just click on this three buttons over here. So you will actually see the full listing or the options under ECR. Under ECR, go to public repository, and you can create a public repository. If you click on repositories over here, you will create a private registry. Okay, so here you will create a public registry. But if you want to see all the public registries which is available on AWS already inside ECR, you can click on this. Okay, and then search for Nginx. Now you can see that the Nginx has come up, and this is verified account, and this is from Nginx itself, and it has 1.3 billion downloads. So you can click on Nginx over here. Okay, and then there are these options over here where you will have the description, you will have the usage terms and conditions, and then image tags and everything. Okay, currently stable Perl is the one which is the current version. Okay, now you can see the URI over here already. So the URI is here as well. So just click on copy and paste that URI in this image URI location, and make this as an essential container. Essential container means this is a mandatory container, and this is going to be the default container. You can also add other containers as well. So you can create another container by clicking on add another container and add another one over here. Okay, so the two containers will be created as part of this task. Okay, so now that this is completed, now I'm going to use the port mapping over here for port number 80, TCP, and HTTP protocol. So this port number is added as well. Now you can make the root file system read-only as well, so that's up to you. And virtual CPU is 1. So I want to assign 1 virtual CPU and a hard limit of 1 GB and 0.5 GB as soft limit. What this means is that hard limit means the maximum utilization of this process or this particular container is going to be 1 GB, and this 0.5 is a soft limit for the same thing. You can add environment variables here if you have anything. Logging is enabled using CloudWatch. I'm disabling it because it requires extra money. And here you can enable restart if you hit a exit code, or if you can see the reset period of exit code. You can also use some parameters or shell file scripts to run as a health check. You can also have startup dependencies if you have more than one container. You can also have the container timeout settings over here. Network settings, Docker configuration, like for example, when someone logs in, what is the command it needs to run, which folder is your worker directory, likewise the entry point. And then resource limits for ulimit. Ulimit will be default, but you can add ulimit over here. You can add labels as well as part of this container. Storage is default, monitoring is default, tags if you want to, you can add it and click on create. This should create your container. Create a task. Now, once this task is created, so you see that it is using the container HTTP image from this repository. So that this is like the soft limit and the hard limit we have given over here. So the container would maximum use one virtual CPU and 1 GB of a total RAM consumption on the container instance. So now this is pretty much what we wanted to configure over here. And these are all the items. So this task is not executed. You need some service to execute this task right now. The task is created. For me, it says revision 4. For you, it will say revision 1 because this is not the first time I'm doing this. This is the fourth time I'm doing it. So I've did it for some other purposes and stuff. So likewise, so you have namespace created automatically and you have the cluster. So go inside the cluster, select the service, click on create. So this will be creating a service for us. Now in this service creation, we have all these options, which is going to be helpful for us to create the service. Now let's go one by one. So now we are here to create a service. So to create the service, let me just reiterate the topic. Go to cluster, select the cluster name, and on the bottom you'll have the first tab called service, and then click on create service. Now once you're in the service, then you can see that this is blocked out because this is going to be the name of your cluster. And here also it's blocked out to say that it is EC2 instance because your cluster is configured on EC2 instance. Now here there are two options over here for your compute configuration. One is like capacity provided strategy. Another one is like launch type. So if you're selecting launch type, you can actually go for EC2 because that's the deployment method for your cluster. If you're providing, if you're selecting capacity provided strategy, so here this is to launch your, strategy for your task. Now, how you can launch this strategy is by having multiple capacity providers for you. So by default, you will have only one, which is your capacity provider, as in this cluster. So that would be your capacity provider, the component inside your cluster. You can also alternatively combine this with a Fargate service as well and Fargate spots instance as well. And you can also prioritize. So we're not going to do that right now. We're going to go with the default one at this program. And then the deployment configuration is that whether you want to deploy it for a task or a service. Now, if you are doing it for a task, it's mainly recommended for batch jobs, but not for web applications, something like what we're going to achieve. Because this task is basically it will run and then gets terminated and then comes back, and if you want to run again the task based on your schedule, it will run it again. So that's like a batch schedule. But a service is a process which keeps on running indefinitely and until you stop it. So we will choose service over here. Now you can select HTTP task over here. Revision is latest, and this is the latest revision over here. And here you need to give the name of the service. So it's mandatory. So here I'm giving HTTP hyphen service. So that's going to be the name of the service. And here I'm going to say replicas, place and maintain a desired number of tasks across your cluster. I'm going to give only one. So this is the only task which is going to handle. And in terms of deployment option, by default, rolling update is presented, and 100 and 200% as minimum running task and maximum running task. What is minimum running task, maximum running task? So if I have the desired task state as 4, and if I have both as 200 or both as 100, so it doesn't matter, both as 100, it means like it will start 4 jobs altogether. It will not wait for one job to complete and be successful and then go to the next job, as in like one task to complete and then it will not go to the other task. It will all start, all tasks together, which will increase the load on your system, which will, if there is a failure on the previous task, it won't stop it. So something like that. So if you give a variation of 100% or a variation like this, you will have one task starting after another. So that's the reason we give this variation. We have deployment failure, in which it will roll back to the previous version if you already have an existing version and you're updating that. And then some of the options over here in terms of service discovery, service connect, and here we are going to use the same security group over here. and load balancing options are being mentioned here. So we are not using any load balancing option. Automatically it is scaled, and then volume is all like completed and tagging is all done. So this is pretty much, and then click on create. This should create the service. Now it may take some time because it will again go to CloudFormation and it will start writing, executing some programs towards creating the service for your application. So this is going to take some time. It may take about 5 to 10 minutes again to get all this sorted and get you to that state of running. So currently you can see that there is no progression over here. It has not started running the task. Now when you click on the task, you can see that it is still in pending state. So slowly and surely it will start executing the task, which is basically the task with definition which you have created over here. So this is the task definition over here. So this is basically creating the container, which is HTTP Nginx container from this repository. So this is pending. So it may take some time to get this completed. So one task is running. I think it's done. So just click on it. And you see this container instance over here. So you have got a container created. You can see that it's in running state right now. Still provisioning. It may take some time to reflect the changes. Now click on container instance and you will see that the total instance here, it's public IP address and everything else on the resources and networking over here, task, attributes and everything. So it's coming up in here, the container instance state. So let's just go to the cluster. We just need to see it running. So it may take a while for it to reflect the status, but the task is completed. Let's see the CloudFormation. Still creation in progress. So let's give it some time. It should take about a couple of more minutes and then it should come in with a proper status. So I'll pause the video until that is completed. All right, guys. So I want to end this video in this note that we have successfully deployed it. And if you're trying to browse it, it wouldn't work. The website on the Nginx, if you're trying to browse it from the EC2 console, right? So the instance over here wouldn't work for you because it's not like, I mean, there are a couple of fixes I need to do to get that working. So I will do it on the next video, but if you're really interested to continue with this journey of ECS and to get that working, so you can follow the next video and get that done. But do remember that it's not going to be part of your exam. So the hands-on itself is not part of your exam. This is just out of my curiosity. I'm giving you this bits and pieces of hands-on. So any which ways I've covered you the topics for the exam. But if you want to go beyond that, this video and the next video will really help you out to shine on ECS. Now, do remember that if you're trying to browse this, it's not going to work. So if I just try over here, it will work for me because I fixed it. So this page wouldn't come for you. You will not be able to connect to this server as well. So if you right click and try to connect it, it won't work, but it's connecting for me. Okay, so now I fixed it. I'm gonna show that how I fixed it on the next video. So thank you again for watching this because it's been going on for some time now. So I want to give the next video a chance for me to fix it and show it to you how to fix it. Thank you again for your time and patience. I'll see you on the next one.